Okay. Can you hear me now? Okay, okay. Check, check, check. Check, check, check. Can you hear me? Oh. Okay. Damn. Okay, sweet. Oh, hey, Paul. How's it going? Oh, okay, man. I'm so sorry about that. Like I said, I am new to... Well, I said it, but you didn't hear me. But I don't stream very often. And I had the wrong monitoring option. In case you use OBS, I did monitor and mute output because for some reason that made sense to me, but apparently that muted everything. So I'll start from scratch. I'm so sorry about that. Also, I have some music playing in the background. I couldn't get it working with my computer. This is just some old laptop that is not that powerful, so I apologize. Okay, let's get started again. Okay, so hey there, I'm Cooper. I go by Relic SE, whatever. And I contribute a lot to CircuitPython and stuff like that, and I love this community that we built and everything. And one really awesome member of the community is Tod Kurt, or Todbot, right? And he has been huge working on Synthiota, right? Synthiota. I was getting ahead. Synthio, right? Which is a system built by Jeff Epler originally a couple years back, built within CircuitPython, and most boards I believe have it. That basically lets you generate waveforms, do subtractive synthesis. Also, you can do some crazy sampling with it and stuff. And then we've also built on top of that some audio effects, and you can use mixers and all that, and play wave files, etc. Anyway, you can make really cool stuff. Anything from synthesizers to drum machines to background music. I don't know, whatever you need done, right? Anyway, so he's been a big proponent behind a lot of this, especially in the hardware side of it. He's done a lot of the software too, but and I've kind of been following his work for a while now. So I have a few examples. First of all, I want to show off. He does some awesome touchpad stuff, and I'll get into the touchpad stuff in a little bit here. But this Pico slider toy, which I believe... Okay, I don't want to pop it out. Might be a little tough there. But he uses a Raspberry Pi Pico and a bunch of capacitive touch pads, which I will get into, to do rotary encoder-ish stuff, sliders, buttons, etc., and a little screen. I've used this for HID mapping and stuff to control a computer and media playback, stuff like that. Pretty cool. But let's move beyond that to the Pico Test Synth. Now, and he has a couple other versions. These are just the ones I have here. So once again, we have the Pico again. You'll see reoccurring there. I don't know what it is about the Pico, but it's just a fun device to work with. Great support from Raspberry Pi Foundation, and it's cheap. In fact, you might notice. Don't look at it, but I have a kind of an aftermarket one on this guy, mostly because of the USB-C. It's just some AliExpress bad guy, whatever. But anyway, even then, the official ones are really affordable, and I love that. I think affordability is really important in the projects that I make, right? Because if we were making $200 devices, then heck, we could put a computer in there, a Raspberry Pi or something at that point, a full single board computer. Anyway, so you see the Pico here, that's kind of controlling everything. It's got CircuitPython on it, etc. And then we also have this I2C display. It's an SSD 1306. It's a little OLED. These are really common. You'll notice in some of the other stuff that we're going to look at, it's actually going to use SPI or SPI for the display technology. And there's a little bit of a performance boost there. It's nothing crazy. And then we have some MIDI in and out with some discrete components you can't really see. In fact, it's hidden underneath the display, but it's cool. You'll notice this guy, which you'll see a lot. I don't know if I got it centered up right. Which is the PCM 5102. It's a classic, cheap Amazon DAC, right? They're actually kind of hard to find the components for sometimes, I've found, when using them on your own projects. But it's pretty cool. And all you have to do is give it I don't think it needs any configuration. You just have to give it a valid I2S signal, and it'll automatically pick up the sample rate, etc. So it's really easy to work with. and provides line output, but you can actually use headphones with it too. Let me increase some of the zoom here so we can see a little bit better. There we go. I just noticed I was getting out of the screen a little bit. Okay, cool. So this is the first one, and we have a capacitive touch here, which capacitive touch in CircuitPython is really easy to do because all you need is a single GPIO line, which I don't know if it's restricted on other MCUs, but on the Pico, you can basically use every single GPIO pin as a touchpad if you want. And you just need a little, little copper pad there with a 1 mil resistor. I think you probably use other resistor types, but that one's pretty easy to use. And what it does is it pulses almost like PWM in a way, pulses a little bit of voltage to that, and then it sets it into an unstable state, maybe, I'm not sure. And then the resistor pulls it down to ground, and without your finger on there, it goes down to ground pretty fast. But if you put your finger there, your skin has a little bit of capacitive touch, right? So that some of that voltage kind of gets into your skin, your body, whatever, and then kind of ekes back out, so it takes a longer period of time to get back to zero. And that's how it determines whether or not you're touching the pad. And if you're smart about it, you can actually use that to control some sensitivity based on how much skin is in contact with the pad. So you can do like velocity sensitive stuff or whatever. Pretty cool stuff. But there's a little bit of an issue when we go from the original Pico to the Pico 2. We actually have a revision here. It's very similar to the Pico Test Synth, but it's the Pico Test Synth 2, I believe. And you'll notice with this guy, we actually have to switch between 3.3 volts or ground as that sync. And the reason why is because when the RP2350, 2350 came out, it had an errata E0 or something. I can't remember. But basically, it doesn't pull down super well, so you have to pull up instead. I don't know. It's super weird. And you'll see here, we do have a Pico 2, but this is actually the Pimeroni Pico Plus 2. It just has a little bit of extra flash and some, nice connectors and stuff. I just use it for testing and stuff. But beyond that, it's about the same board. You got some ADC pots here, basic stuff. And then that leads us on, I'm going to push these out of the way, to the Synthiota, right? Now, this is new from Tod. And I haven't played around with it yet because I just got it in yesterday. But it just basically takes the concept of the Pico Test Synth and amps it up a bit, right? So we're going to have our Pico 2 there, obviously. And we're going to have our OLED here, but I'm going to use SPI for it. Should be like slightly faster. We'll see. We got some MIDI in and out, and which I didn't touch into too much. We have our PCM5102. Which I gotta say, it's a good DAC. It provides good solid line output. Man, I'm a little surprised they didn't go towards the TLV 320 or whatever series and get something with, headphone output, speaker output, stuff like that. But maybe we'll see that in a future revision. We'll talk about it. Okay, and then we have a bunch of area for pots here, up to 8 pots. I believe there's a little bit of a chip here, the 4051 classical analog multiplexer there. So you can use all 8 pots. I think normally the Pico only can handle 4 ADCs at a time, so you kind of have to switch between the banks, is my guess. And we have a little encoder spot, and you'll notice there's a ton of LEDs, right? Which is awesome. These are NeoPixels, I believe. They're soldered behind, so really clean. And then we have a bunch of touch pads, which I think they're velocity sensitive or something, because there's like half and half. I have to look into the code for this. But we're actually using NPR 121s here, which are I2C based, touch sensitive, little chips. That will give us a lot more touchpads to work with, as well as a bunch of other I/O. So that's awesome. So we got some sliders, stuff like that. Anyway, we need to get a business here. Let's get started. I'm gonna start, as everyone does, which don't take this as a, soldering guide per se. Let me zoom in a little bit. Oh, can we zoom? Whoa, it went a little too far. I want like 150. Did that even zoom? What's going on? Okay. Let's do a little more than that. 175. There we go. Lovely. Cool. So we're gonna start by putting in a Pico 2. I have, from my Adafruit, a bog standard Pico 2, nothing special, but it should be what we need for this project. Woo. And we're gonna put that in first. So with soldering, I don't have a guide for this or anything, but generally you want to start out with the lowest profile stuff. Your SMD, passive components, things like that. Because as you kind of get higher and higher up the food chain there, it's gonna be harder to get behind. Now this is gonna be a very basic soldering task, but it's something to keep in mind. And I have my soldering iron here. I'm using like a angled tip. I think it'll be fine for this project. And I've got mine like 650 Fahrenheit or so. I'm not an expert. I do my best. Oh, I didn't even show off. I do have a case printed out for it that Tod designed. I need to do some cleanup on it, but it'll work for now. Maybe we can get to installing that. Oh, here's this little thing. Okay, cool. So, super big trick for the Pico, because we're gonna use the castellated pads on it to get it really slim profile on the board. I'm gonna use these little pin headers to help us align. So I'm gonna put some in over here, and I'm gonna put some over here. Not just make sure that everything is really lined up, and if you're really good at it, you'll use a little 3-pin header over here to line up that debug port too while we're at it. And let's get started. So I will say, for the sake of noise, I have a fume extractor, but I'm not gonna use it. And I apologize for that. But this is a pretty well ventilated house. I think I'll be okay. Yeah, and then we're just gonna go down the line. Now, with almost any chip I see, or in this case the Pico here, I'm gonna start by tacking the corners, because if you just tack the top left corner and the bottom left right corner, and then you can adjust them by heating up each pad so you can make sure that it's perfectly straight for your practices. How much hair are we getting in with this? A little bit of hair. I'll try my best to not get my head into it. Okay. Now, you don't want to put too much solder if you don't have to, right? So I've tacked the corners, well, one corner. Oh my God, can I tack the other one? Come on. Sorry, iron's just probably getting hot. Okay, and then let's check. How does this look? I'm seeing the holes are lining up. Yeah, good enough for me. So once you get those, you can basically take these little pin headers out and then get to work. Now the ground pins, which are indicated because they have a little, like, instead of being rounded on the end, they're squared. They might take a little bit extra heating to get right. But the GPIO pins should be pretty quick. I say that, and here I'm having some trouble. Now, another thing I would love to see on a board like this, and I could probably extend it, just like a little module or something, is LiPo battery support. Because I'm telling you, if you get LiPo battery support and a headphone jack or an onboard speaker, then you could take this thing on a car, plane, train, automobile, whatever, and make music, right? Speaking of, let's talk about the software a little bit. So right now, there's some test hardware, firmware that you can get, but there's also kind of the showpiece is TB-ish, right? Which is designed after the TB303, which is a classic kind of acid bass synth, right? So you can do some funky sounds with that, and it's kind of a starting place. Like, he's got some good sounds going on using delays, distortion, etc. Sounds fat, but I think there is some room for improvement there that Todd's working on in order to make it a little bit more useful as far as like creating sequences and stuff like that. And I would love to see that happen. I want to pump my temperature a little bit. What I would like to see on this, and I think I'm going to work on, is a simple drum machine of sorts, right? Because we have with these LEDs and the 16 pads, it's kind of perfect for a 16-step sequencer, right? So I could see you just select your, select the voice that you want to control, kick, snare, etc. And then as it's running through, you can select the pads you want to be affected. You could expand upon it endlessly, really. And of course, it'd be good to see something that's a little more synthesizer focused. However, we don't have a standard piano roll here. We just have this this thing, so it would be a little bit different. Like, maybe you could have it so it's pre-selected for a certain scale or something. We'll have to see. Come on, heat that sucker up. There we go. Maybe the big chisel tip wasn't the best for this job. Okay, cool. How are we doing? We're doing good. Hey, feel free to say hi in the chat, Tell me what you're working on, what kind of cool projects you got going on. If you'd like to see anything, for out of this project, the Synthiota, if there's some kind of dream you have of a cool interface, synthesizer, etc., I'd love to hear it. Oh my god, I can't get this to adhere. Come on. Now, I've been doing a lot of work in Fruit Jam land, working on game stuff. But I'm kind of excited to get back into the synthesizer side of things, right? There's a really good foundation now, but I think there's even room for more development, to make more finalized products and stuff like that. Now, in the past, and some of y'all might be familiar with this, I've worked on, here we go, the Pico Synth Sandbox, which is kind of a precursor to this. I have like 2 different revisions of it, and it was good, and I worked on a lot of software for it, but it had a lot of hardware issues. I wasn't doing things completely the right way that I think Todd has kind of got figured out a little bit better than I do here, A big part of that is touch inputs. Like, all these touch are being directly controlled by the Pico straight to GPIO, so it limited me a lot. Also, the screen. I don't know what came over me, but I wanted to use a 16-character 2-row display LCD, right? And that was a terrible idea because A, it uses a ton of power to light it up and everything, the backlight, and you're limited. You only have text, right? And so I couldn't show things like graphs very easily. And I don't know, and the refresh rate was slow. It was just a bad idea. I should have used an OLED module like this, or heck, even like directly soldered one or something. So I see someday revisiting this guy, but I don't know. I'm not there yet. I'd rather play around with this. But the cool thing, this is all written in CircuitPython. There's a lot of hardware abstraction in CircuitPython. So, if we develop some really cool software for this device, it can be ported to other platforms very easily. Come on. There we go. Man, I'm just not getting the heat. Now, I'm not using any flux here. However, the solder itself does have flux on it. I could go through the process of adding flux on and then, cleaning it and everything with ultrasonic cleaner, but I figured it would be faster if I just did it this way. And I'm not too worried. Come on. Okay, cool, we're getting movement. So I'm here in the power section. Sometimes some of the pads here can be a little tricky because they're a little bigger. A little bit more copper to heat up. Okay. A little FYI for y'all, in case you don't know, but the RP2350 actually has like a built-in, I think it's like a buck converter, some kind of DC to DC power converter. So you really only need to give it like, I think 3.3 volts. And then give it a few passives somewhere in this power region. And then it converts, 1.8 volts and maybe something else out of that pretty efficiently. It's just kind of interesting. Okay, not the best looking. Come on. I think that'll do it. Yep. Connections look good for the most part. Sweet. Okay, let's get to the fun stuff. I think the LCD and the PCM, the DAC, are going to be next on the list. Cool. So I have this here right out of the box, fancy schmancy. I don't know where it came from. But it's a SPI OLED, which I believe should be compatible. Let me double check. It is compatible. Yay. Oh, wait. It's really small. What do we think about Okay, maybe I should have done some background research here. It's a bit smaller than I anticipated. What do we do about that? And it's not gonna line up here, is it? I have a desoldering gun. One of these guys right here. I'm gonna solder this on for now. I think it'll work, but I'll look up the different, whatever different spec we have for that module, and I'll use that instead. I'll swap them out at some point. Kind of a bummer, but like I said, I didn't do my research. Okay, another cool thing you'll notice while I'm soldering this up. Also, thank you for all the pads on there, all perfectly labeled, Todd. We have this H11L1. Now, I believe, I can't remember. There's a classic chip used for MIDI. It's like the LM138 or something. But it's kind of old. Like, it has not been updated forever and honestly performs not the best. Okay, that looks good. And this H11L1 is kind of the modern equivalent, right? So I've actually used it on a few of my projects too. I think there's another chip out there that's even smaller that does the same job, but I can't remember the name of it. Okay, let's double check. Okay, so what y'all may have noticed, so there's like a little bit of a gap there. I don't know if you can see that. And I wanted to straighten it out because whenever you solder up first, it might be bent, a little crooked. So I soldered one leg and then went back, kind of lifted it up a little bit and then reflowed the solder on that so I could level it out, which I might want to do again actually. And that helps you get it level. I think that'll work. I might be making a mistake here. Let me look this up. He might want us to use female pin headers. Bot, Synthiota. Here, I'll show you what I'm looking at. Whoa! Okay. Okay, so here's his project, his repo for it. This is the LCD we apparently need. I think I have everything else. Standard header pins on the OLED display. I do have a set of short sockets. It's something like that. Maybe I'll look that up. Okay, let's go back. Let's go back. I'm sorry, go away. Copy. I am gonna go find this piece and I'll be right back. I know exactly where it is. I swear. And I'll be back. Oh. Okay, give me 1 minute. And we're back. I have a hat so you don't have to look at my bad hair. Okay, so I have a set of sockets here, which should be short enough. I don't think I've actually ever used these either. They're fancy. Let's put that to the side. So I'm actually gonna undo my work here just a little bit. Get that desoldering gun warmed up. And we'll get back to it. Okay, come on. Haven't cleaned this thing out in a little bit, so hopefully it's not too bad. So it's gonna take forever to heat up. Well, let's while we're at it, let's go ahead and clip these header pins down. Okay, so I'm just gonna measure it out. There we go. That should be perfect. Still not hot enough. And actually, I have bad news. I couldn't find an extra one of these DACs here. So I'm actually gonna have to desolder it from this as well, which I wonder, should I use headers on that too? Oh man, I think I messed up majorly here. I think he wanted us to use pin headers on everything. Yeah, I'll show you what I'm looking at. I've gotten so used to soldering the Pico directly on. But yeah, okay, so he's got the DAC soldered directly with headers. But he's using short headers for the LCD. And then he's using short headers for the Pico. Man. My bad. That's what I get for not following directions. Okay, so these things are amazing. Actually, I should show you the camera again. There we go. Because they make the job of desoldering a million times easier. I usually just put it on there, wiggle it around a little bit, get it hot, and then pull that sucker out. There you go. And not quite free yet. Oh, actually, take it back. We're free. Easy peasy. And then let's restart here. Same deal. I'm going to put, and I'm going to leave my desoldering gun on. I think we're going to need it here in just a little bit. I'm going to tack one side. Cool. And then I'm going to kind of feel it up a little bit. It's close. Yeah, I think it's good enough. And then start soldering the rest. Whew. Real smoky. There we go. And that way, our screen will just pop right in there. If I can get it. Oh, you know what? I think I might need to put short headers on this too, some male ones. One thing at a time. So well prepared for this. Okay, let's get this guy out. And let's desolder our old DAC module. Hopefully it won't take too much time. Sometimes the ground pins can be really stubborn. This out of the way. Let's see, will that be enough? Might be a little little stubborn. Somebody's holding on. Let me go back through it. Sometimes I'll add solder and like restart basically, and that'll help. But I think I see the one that's problematic. Two of them actually. Let's see. And I'm just using this curved guy here to push up on it from behind. No, it's not wanting to go. Oh! We got movement. Something else. Okay, this port's good, but something on the other side is causing problems. Talk about anything? You know. I mean, heck, I'll talk about global events if you want me to. I don't want to, though. That's like the least thing I ever want to talk about is global events. Oh! I think we done it! We done it! It's out! Boom! That's a miracle. Relatively clean, too. Sweet. Cool. So that sucker is gonna pop right in there, finally. An easy job. Let me... a little misaligned, so let me get this right. There we go-ish. It's a little wonky. But not bad. Not bad at all. Let's get to soldering. Okay. Okay, let me double check. Yeah. Cool. Yeah, this is going way quicker. This soldering iron is heated up pretty well. Needs a little more flux. Okay, that's good. Normally when I'm soldering like this, I get my head like way in there. But I don't think y'all would be able to see anything. Cool. Do some of these pins over here. Okay. So, we have any gamers out there? You may not know this, but I'm a little bit of a gamer. But I have weird taste in games. Recently, I've been playing Dragon Quest I, the original, but not on Famicom. I've been playing it on the Switch. But I think it's like the mobile port or something. All I know is it was cheap, and I just wanted something cheap to play that was a JRPG. But I've basically beat it now. I'm in the Dragon Lord's dungeon, and he's basically the final guy I gotta beat. But I am looking for Erdrick's sword. The sword of Erdrick. And then I should be able to beat him. Cool. I think that's good. Okay, so he calls for PJ 320A jacks. These are not that, but I think they're really similar. But they're meant to be surface mount, right? In fact, you'll notice on here, they're the exact same kind that's used on this module. But I'm thinking, I don't know. I don't think it's gonna work. It doesn't quite line up as good as I was hoping. Ah! I mean, it's okay. That's just for Midian, which I'm not really gonna be doing now. So we'll skip that. So no Midian. But what we will do, and now finally, for the fun part, is we're gonna do all the knobs. So we have our encoder, which is switched. It's an EC11 or something. Oh crap. Oh, I didn't line up all the pins. Okay, yeah, I don't have that many tricks with this. I guess line up the pins before pushing it in. Since I just screwed that up. Okay, line up the pins, push it in, and it should hold, right? So it's holding on there pretty good. And then we're gonna go through, what are these, RK 103 something something something, I don't know. I got a big bundle of them a while back. So line up the pins, and then push in the clamps. Oh, come on. Yeah, there you go, good snap. Oh, and check it out, I got these cool little knobs, which will match-ish our pea green case. Just barely, they'll just barely match. We're almost done though. If I can just line these up. You know, I think if you're smart, you would like pinch in the sides just a little bit before doing this. But I never said I was smart. Okay. Pinch in the sides just a little bit. Come on, come on. Oh, this one, the pins are a little weird. Okay, okay. Pinch in the sides. Cool. And this is gonna be a piece of cake to solder. It doesn't get easier than this. You know, speaking of these jacks though, I do wonder why he used to have a S&D solder, and then he went for through hole. Even though the exact same jack. Exact same jack. You know what? Because it's on this side of the board. And he only did populated parts on the other side. So in order to make it... okay, that makes sense to me. I have to admit, though, I'm a really big fan of S&D soldering. I think it's actually easier than people think to do. You know, as long as you're not doing like 0402 parts. If you're doing like 06, 03, 08, 05, super easy 08, 05s, then I think it's cake. Like, I think it's in a way easier than through hole. Because, you know, you don't have to flip the board over, you don't have to bend legs, you don't have to clip after. Like, it's definitely, if you have to solder 10 resistors, I would rather do, you know, 0805 SMD, you know, one at a time, than through hole, you know, 8th watt or whatever. That'd be so much easier. Okay, look at that. Oh, we got our knobs starting to come together. Okay, flip that guy over. And because, you know, these hold pretty darn well, I don't think we'll need, you know, to be careful about it. I think we just got to solder a bunch, get to work. So I'm going to start with the retention pads. You know, just heat it up, Throw some solder at it. Yeah, it looks good. And you'll notice I'm actually putting the solder on the pad itself rather than on the soldering iron. So it flows a little bit better. Man, you can use a lot of solder on these though. They just suck it up. And here we go. So as far as firmware programming is concerned, Tod has a UF2 file ready to go with TB-ish on it. Well, I mean, maybe some hardware tests too, I hope. I think I'm just gonna do that to get started with. And then I'll update, you know, the firmware and everything after the fact. But that'll be as quick, as simple as just dragging and dropping it, really. So nothing to worry about there. There we go. Man, we're sailing. Oh, where'd you get the P? Okay. Okay, Dan Lavin, D2S, right? Yes, Tod doesn't have it for sale. That is true. I asked very nicely. Well, sort of nicely. And, you know, we've worked together a bit, so he was gracious enough to send me one. I think he only got, like, probably 5 made. By the way, I don't know if I should disclose it. Well, it doesn't matter. He uses JLC PCB, which I actually use as well. I think the prices are really fair. The turnaround time's really good. They're ordering utilities super easy. I highly recommend it. I actually have some shipments coming in today. That'll be my first PCB-A, which is assembly, right? So they're gonna do some of the SMD components and stuff for me. And we'll see how well that goes. Maybe I'll post a little update when I get it. And I think he used the same service here. And, you know, by the looks of it, it looks really good. Anyway, so maybe if you ask Tod nicely, but I think this might have been the last one. I don't know if he's planning a hardware revision before he starts selling them. If you're not familiar, he has a Tendy store that he sells his stuff. Let me show off his Tendy. And by the way, if you're getting into making your own electronics, I recommend Tendy. It's not incredible or anything, but it's pretty good, and it's really catered to, you know, us tinkerers, DIY projects, stuff like that. So I recommend taking a look. Did it load? Sorry, this computer's really slow. And it's doing the live stream right now. It's probably screaming. Also, you know, hey, we have on here little Google search results. Check out CircuitPython show. Paul Cutler runs that, which he was here earlier. Awesome little podcast. He does a really good job putting it all together. You know, I think him and Tod work a lot together, so take a look. Come on, let's go. Hey, my internet's bad. All that upstreaming. Okay, well, it's not wanting to pull up right now. I don't know why, but check out his stuff on Tendy. It's... Ooh, wrong one. Here we go. It's pretty good. He has a lot of stuff, like some of these other projects I showed off. Oh, you're still here, Paul. Awesome. Some of these other projects, like the Pico Test Synth and all that, are up on there, as well as some PewDiePie stuff. I don't have any of those. Even though this is definitely the creme de la creme, you can still do a lot with the Test Synth, and so on. So I recommend taking a look. You can, of course, breadboard some of this stuff together, too. I mean, I do recommend that, especially getting started. But if you want to like really focus on the software, it's kind of good to not have to worry about the hardware. You know, one thing at a time, right? And these platforms basically give you an opportunity to like just focus on CircuitPython, right? Like, you know, hey, your DAC is connected. You know, your pads are all oh, yeah, and pads are really hard to do with breadboarding and stuff too, unless you got like plugged into bananas or something, which is a thing. Okay, I am almost done. Okay, there we go. We have a little bit of a problem, and that's that this display has the wrong headers on it. Yeah, I can't get it in there. So, I am going... Let's go ahead and desolder these headers, and I'll put the right ones on. But I'll have to go and grab those headers from my secret stash in the shed. Yeah, if y'all have any other questions, you know, let me know. I'll do my best to answer what I can. You know, I've been doing a little bit of work with Blinka lately, which, if you're not familiar with, I'll do my best to describe it. It's basically the CircuitPython APIs, you know, display I/O, digital in out, etc. Okay, here's another trick here. If you have headers and you don't care about them, you can take your clippers and just clip every single one. And it looks nasty, but it'll make them super easy to take out. So now I can literally take my tweezers. Okay, that one's not ready. Oh, that one was still not ready. Come on. Okay, I didn't do a good job. Anyway, okay, back on Blinka. So it's basically, you know, you have CPython, right, which is basically native computer Python. That also runs on, you know, Raspberry Pi, single board computers and stuff. And so it's basically conversion of the APIs within CircuitPython to be compatible with those with single board computers, but really computers as well, because it's just CPython. There's some features like digital and I/O and stuff like that, which is more catered towards, you know, Raspberry Pi computers. There we go. Anyway, so when, you know, doing all this work for the Fruit Jam stuff, making games and stuff, I found it to be kind of a pain in the butt to have to jump between my computer and my Fruit Jam a bunch. You know, obviously I love the Fruit Jam, but when you're just iterating on small changes, that was kind of annoying. So I started looking into Blinka, being like, well, you know, can we generate display output? Can we basically make these programs compatible with a native Python environment? And the answer is you can. It requires a little bit of work. Some small conversions here and there, right, to get everything working. And I did that on the show and tell recently. I showed that process off. So I recommend checking that out, and I'll share more information as I learn more. But it gave me a good idea when, you know, thinking about this project. I was like, well, shoot, maybe if you want to, you know, help improve development of synthesizers, drum machines, stuff like that, if you could render the same audio through the same APIs, etc., on your computer and do some tests, etc., you know, hardware abstraction stuff, that might make it easier to, you know, play around with different, you know, sound pathways. And then once you got all that ready, you can transfer that over to your actual embedded single board, well, not single board computer, but your embedded platform. But unfortunately, there is no audio system in Blinka at the moment. So I was actually talking to Melissa, maker Melissa, and and Scott about it, and I don't know. There's some room for development there, and so I might look into it to see if that's something that I could help with. But if anyone else, think that's up their alley, that'd be really cool, because I could see it working for a lot of stuff, right? Anyway, we're gonna take another quick break. I'm gonna put up my coming soon, and I'm gonna get those headers for this guy so we can plug it in, and then we can program it. Okay, I swear. I'll be right back. So I'm back, but bad news was that I could not locate the special pin headers that apparently fit these short headers. Unless they're in here. That'd be really funny. Oh my god, they're in here. I must have combined them at some point. Well, I did all that running around for nothing. But that's okay. I did grab a USB cable for programming. Okay, cool. So I guess we have these short little headers here, and we want to add them up. Okay. There we go. That's looking good. Let's get one tacked down over here. Cool. And then let's just straighten her out by eye for now. Be careful not to burn yourself when doing this, because it's kind of easy to do. Okay. That looks pretty good. Cool. And then let's go to town. There you go. Easy. And this better slot in, I swear. Oh, look at that. You know, it's not that much shorter. I gotta be honest. We'll see. Well, hopefully it's the right size for that case. If not, I gotta do some orders here. Okay, next order of business. Let's go ahead and program it before we close things up in a case. I have a cable here. It's the official Raspberry Pi one. And I'm going to plug this guy in. And then plug it in. Now, if there's problems, then, you know, things probably won't load up at all if I, like, bridge something, which I don't think I did. So, okay, cool. So we have a little light there. Let me clean this up. So at least we have power. And I have the drive on my computer. Let's show this off. Show off how easy it is to program a Raspberry Pi Pico. So we have it over here, Synthiota. And I'm just gonna go to the main repo, and then there should be a releases tab. Here we go, demo one. And then this should have a UF2 file, which is basically a packaged firmware file for TB-ish. Awesome. And I'll probably do some more intensive hardware tests to make sure that everything works, but hopefully this just works. By the way, in case you're interested, I am using Manjaro here. Oh my god, so much crud. So I'm just gonna drag that up. Let me just copy. Manjaro with, I believe it's KDE. It's honestly not my favorite. This is my first time using Manjaro, was on this computer. And I kind of prefer GNOME and Debian. Like that's my favorite go-to. However, I actually moved over to macOS recently, which sounds crazy, but the reason for so was because of ARM, right? Like it is so efficient and yet so powerful. It's just insane. So I don't know. One of these days, I forget the project. There's a project that's trying to make Apple Silicon work with Linux and stuff, and hopefully that comes soon, because that would be sick. Okay, okay, we got LEDs. We have LEDs. I don't know if everything else is working. I don't have an audio input. Oh, let me get a jack. Oh, there should be one right here. Okay. I should be able to handle this. Okay, I have a bass amp, right? I'm gonna plug that sucker in, and then I'm gonna take the line out, and then it has RCA jacks, which this bass amp has an RCA input. And y'all should be able to hear that. Or it might blow down the house. I need a power cable. Power cable, come to me. You will do. Okay. Power to the bass amp. Let's reset this. I'm just gonna unplug, replug, because I think the LCD is not working. I need to do a hardware test, but oh, I don't have power to my bass amp. Okay, bass amp has power. This is not promising. I will be honest. Okay. I'm sorry. That was loud. Well, sound works. I don't know if the display isn't working. It could just be that this is the wrong LCD and it's just not set up for it. That is very likely. Because I don't know what knobs I'm twisting. Let me just turn everything down and see what happens. Okay, it's coming in hot. So it's really weird. The way the line input works on this bass amp is it overrides, like it's just full output, right? So I can't actually control that. I need to control it from here. And he may not have put in a volume control, which I wouldn't blame him. Let's look at our screen. So I'm gonna open up Thonny here, and we'll do open. So Thonny is a Python interpreter-y kind of thing, but it's really good for testing stuff. You can see the REPL in the bottom, and then you can open up your code directly on the device over REPL, I think. So if you don't have USB drive stuff set up on your device, it'll still work. Okay, so we're okay. Per step latency, awesome. We're overclocking the CPU, importing all of our stuff. I want to see where he's got audio mixer and stuff running. Where's the output? Let's open up another thing. Synth test GUI. Okay, TV-ish. Synth setup. TV-ish. Sequencer synth. Maybe that's it. There we go. Okay. TV-ish synth. Okay, this is probably where he's got stuff working. Synthesizer. Where's the audio output? That's probably done elsewhere. Okay, so sequencer. There's the synth and this TV audio. Let's add audio mixer. So where's the mixer coming in? Oh, it's creating this synth setup, Synthiota. Okay. Okay. Synth setup, Synthiota. Open that up. And here's our problem. So sample rate. Oh, you couldn't do 44.1. Interesting. Let's audio play mixer. Oh. So it's already pretty low. Let's make it even lower. Okay, so I'm going to change that, save it. I'm going to go back to our code.py. I'm going to play that out. Okay. Is that peaking? It's peaking. I'm so sorry. It's too loud. Maybe I can turn the gain down? Mixer.voice 0 level 0.1. Let's go. It's gonna be loud, I can't help it. I think that was the drive. There should be a delay on this too. display worked, I'd know what's happening. Oh, y'all are seeing weirdness. Doesn't like something. Maybe the drive was too hard. I don't know. Sorry, I'm just jamming now. I don't know what I can tell you. Okay, well, I got some issues to work out here with the display and stuff, and I haven't even put it in the case yet, which I don't know if it's ready for the case, but progress is better than no progress. So hopefully by the time I've really tweaked on this thing and got it looking pretty, then we'll be good. Oh, I'm really curious. Oh, I have to get that display. I mean, it kind of fits in there. There's just gaps. I don't know if y'all see that. See the gaps? That's okay. Screw it. We're here. Let's just keep pushing forward. Oh, I have to. Oh, okay. Oh, check this out. Okay. So I should check on our chat in case we got anybody. Oh. Okay. You know what? I swear I double checked the pinout though. Thank you for your input, Dan. By the way. Yeah, ground VVD SDK MOSI. On this one it's SDA, but it should still work. MOSI, yeah. Reset DC. It's the same pinout. I don't know what's up with that. So who knows? Okay, but let's put on some knobs to make it look pretty. Let me get this guy on there too. Oh, I don't think that fits that. I can't take it off. Okay. And I think I gotta screw these on too. I don't know what size screws it is. M3 or something most likely. I'll get around to that. Don't you worry about it. Man, I could definitely if you got a bass synth really working on this, kind of like an organ bass, I could definitely see using this. I play bass guitar in a few bands and stuff like that from time to time. That and drums. And I could totally see having this on the side. Oh, we just want a little bit of a synthesizer on this one part. I could totally see that working with this guy. For some reason, this guy doesn't want to fit. What's wrong with you? Let me do this the right way. Oh, I say right way. Anyway, I'm sorry for taking up so much of y'all's time. I'm going to be done here in just a second. But thank you for sticking around. I really appreciate it. Okay. There we go. What's wrong with this one? I don't think it fits that. I have a ton of different knobs around here. I'll pick something else out. If I can find something. Anyway. Well, that's starting to come together. And just snaps on the sides there, this case. Kind of a long print, by the way. It's about 7 hours. But it's worth it. We got little knobs. And I got to clean the case up, too. Oh, this one's a little jammed for some reason. Awesome. Let's leave it at that. VCC and ground. I had to create it. I don't know why. I'm telling you, the one I have, it lines up. But maybe I'll play around with that. Maybe I'll just like, use some jumper wires and see if that makes a difference. Anyway, thank you all for your time. I had a lot of fun. Maybe I'll do this a little bit more often. Do something a little different. And yeah, if you have any other questions, hit me up. I'm on Discord, the Adafruit Discord, Relic SE. I'm on GitHub, etc. Blue Sky, Twitter, whatever. If you just have any questions, just let me know. I had a lot of fun, but I gotta get to work. So I'll see y'all later. Bye, ciao.